Go! All right. This is Pre-Calculus section 2.1, chapter 2. That's right, chapter 2. The 2.1 video, instructional YouTube video. So, learning targets for this video are to graph a quadratic function, identify the vertex, x-intercepts, axis symmetry of a quadratic function, so a parabola. Write an equation of a quadratic in standard form. Previously, we've thought of standard form as ax squared plus bx plus c. This textbook, which we use, that uses WebAssign, they call standard form vertex form. Vertex form is our new standard form. So general form is what you're used to seeing as standard form. When they say standard form, when I say standard form now, I mean vertex form. That's what we used to call it. And then we're going to write the equation of a quadratic from the vertex at another point. We're going to throw in a little bit of completing the square as well. So let's just jump right in and talk about how to graph. So we're going to graph f of x equals 8 minus 2 times x plus 4 squared. Go ahead. Oh, and I want to find vertex, axis of symmetry, and the x-intercepts. If the x-intercepts exist. So go ahead, pause the video, try this, or at least think about how you would graph it while I sketch my grid over here. All right. So you may look at this and be like, that looks weird, because it does. Usually we write it this way. F of x equals negative 2 times x plus 4 squared plus 8. If you're going to reorder it, I said negative 2 and I didn't put a negative there, right? Addition and subtraction are commutative in the sense if you think of subtraction as adding a negative. I think if this is 8 plus negative 2 and I switch the order, I get negative 2 stuff plus 8. It's still the same thing. But if I were just to switch the locations and make the 8 negative and the other thing positive, that would be wrong. That would be changing it. So you got to keep the negative on the term that it's on. So negative 2 times x plus 4 squared plus 8. So here our transformations are up 8, left 4. Boom, that's our vertex. Left 4, so negative 4, up 8, positive 8. Opposite of this number tells you your x number for your vertex. That number tells you the y number for the vertex. Because it's just 0, 0 moved left 4, up 8. So I'm going to go here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Boom. There's my point. 4, 8. All right. Axis of symmetry is always x equals x number of the vertex. It's right here. The parabola is symmetric about the line that goes straight up and down through the vertex. So there's our axis of symmetry. We draw that with a dashed line. We also want to find the x-intercepts. So let's go ahead and finish graphing this, then we'll see if we can find the x-intercepts cheaply. Cheap as in like, hey, maybe they show up on the graph. We don't have to do any algebra for it. It's always worth a shot. So this negative 2 tells us it is a reflection. So our graph is now opening downward. So the vertex is on top. So it's opening downward and it's a vertical stretch by a factor of 2. So instead of having a regular parabola, like x squared, where if you go over 1, you go up 1, over 2, up 4, over 3, up 9. We're just going to double the 149. We're going to keep the x distances the same, but double the 149. So I'm going to go 1 to the left or to the right. And instead of going up 1 like I normally would for a parabola, I'm going to go down 2 because I'm doubling that. So that would be at, oh sorry, this should have been a negative 4. 8, my bad, it's a negative 4. This is going to be at negative 3, 6. So I went down 2 from the 8. This is going to be at negative 5, 6. If I go 2 over, normally I would go down 4, because 2 squared is 4, with the negative. Because there's a 2, I'm going to go 8 down, which plops me right here, or right there. So this is at -2, 0, -6, 0. That's enough. 5 points is usually enough to give you a good general shape of a parabola. So we can go like that, sketch it through, call it good, and check it out. We found our x-intercepts. So we got -6, 0, and -2, 0. In general, WebAssign is going to ask you to find the smallest x-intercept first, like put that one, say smallest to largest. Smallest x value, larger x value. More negative means smaller, remember that. All right, when you're on WebAssign, it says, graph this parabola. It won't have a high-pitched voice like that, though. It'll probably be a robot voice. But when it asks you to do that, what you're going to do is you're going to click the little shape. It's going to look like this. There's going to be a little shape to the side that looks like a little parabola. You're going to click on that. Grab the one that's going up and down. You don't want the horizontal. You want the vertical parabola. And then you're going to put a point right where the vertex is. And then you're going to put another point anywhere that there's another point on that parabola. And then WebAssign it'll just like plop that parabola in. If you have the vertex and one other point, that's enough information for a parabola. Okay, so that's what you're going to have to do for graphing. Some of them, most of them are going to be like multiple choice graphing now. All right, well, let's try another one. So this was in, this right here, this, I said this a lot. That is what we're calling standard form right now. We used to call this vertex form. For some reason, even though it's the exact same author for this textbook as it was for Algebra 2 and Algebra 1 textbooks, he's changed from calling this vertex form to now calling it standard form. So when it asks for standard form in homework, it's looking for this style. So standard form is the a times x minus h squared plus k, that one. All right, so we're going to do another example here, except this one, we are going to do a little bit of algebra, which is fun, to write an equation from general form into standard form. All right, so we've got f of x equals x squared plus 6x plus 4. We want the standard form equation. We want a graph. We'll do that over there. And we want the vertex. We want to identify the vertex axis of symmetry. I'm just going to abbreviate that as AOS. That's not A composed with S, that's what it looks like. We'll just go axis of sim. I know, had I just written it out the first time, it would have taken less time. And the x-intercepts, if there are any, or maybe there's just one. Maybe it's a vertex. That's possible. All right, so let's go ahead and look at how we can get that in standard form. And let's do that over here, because this board feels left out. It's left out on this side. It's right out on that side. Get it? Because this is my right side. Okay. Bad joke. X squared plus 6x plus 4. What we want is we want a times x minus h squared plus k. So what we gotta do is we gotta complete the square. I mean, there's more than one way to do this. Completing the square is a way to do this. It's one way that we could. So what we're gonna do is we're going to isolate the x's. We're gonna say x squared plus 6x plus blank is a perfect square. And then we're going to go minus blank plus 4. And let me explain why I'm putting these blanks in here. So I need this to be something squared plus or minus something. So I'm going to say, okay, well, the x's have to be part of that squared thing. So I'm going to go x squared plus 6x plus some number would make a perfect square. Something times something, or something times itself. But that means I got to add a number in here. If I add something, it's going to make this value bigger. So I'm going to add a number, and then I'm going to subtract that same number. So like, let's say this number was 2. It's not. Let's say it is. If I go plus 2 and then minus 2, that's 0. I'm not really adding anything. So what we need to do is say, what number do I put in there? Well, we're just going to take a little bit of a diversion and we're looking at like x, let's just say like x minus 3 squared, right? If I multiply that out, x minus 3, we get x squared minus 3x plus 9, right? Which is x squared minus 6x plus that. Oh, rats, that's what we wanted. Oops. Now, how does this 6 relate to the 3? And how does this 9 relate to the 3? Or how do they relate to each other? Well, you'll notice this negative 6 is 2 of those. So what we can do is I can take this number, I can divide it by 2, and that gives me negative 3 in this case, and then square that number. Negative 3 times negative 3 gives me 9. And that's going to be our process for this. We're going to look at this, we're going to say x squared plus 6x plus blank. We're going to take the 6 from the x, we're going to divide it by 2 to get 3, square it, and that gives us 9. I add 9 here because this x squared plus 6x plus 9 is x plus 3 squared. If you factor this, that's what you get. And it's always going to be this number that goes here. Always. Just how it works. Because it's algebra. And then here, we had the plus 9, so we had to subtract 9, so we don't change the value. We're not making it bigger or smaller. We're really just adding 0. And then I've got a negative 9 and a positive 4. That's going to give me minus 5. So I can say f of x equals x plus 3 quantity squared minus 5. Here are a values is 1, but we don't need to write it. Cool. I'm going to erase this stuff. Here we go. So now we have x plus 3 squared minus 5. So f of x equals x plus 3 squared minus 5. Hey, we can find the vertex now pretty easily. Negative 3, comma negative 5. Remember, it's always the opposite of this for your x, and that's your y. So the vertex is at negative 3, comma 5. The axis of symmetry is always x equals the x number for the vertex. So x equals negative 3. X-intercepts, let's see if we can get it for a cheap price by graphing it. Because we're going to graph it anyway, might as well see if we can find the x-intercepts. All right, so whoop, there's my x-axis. Y-axis, I'm going to put it right there so I can go 1, 2, negative 3, 4, 5. So negative 3, negative, sorry, this should have been a negative 5. I goofed. It's a minus 5, negative 5. My bad. 1, 2, 3, 4, negative 5. So there's my vertex. Negative 3, negative 5. There's no stretch or shrink, there's no reflection. So it looks exactly like y equals x squared, but shifted left 3, down 5. So I'm going to go over 1, up 1, over 2, up, or sorry, left 1, up 1, right 2, up 4, left 2, up 4. And we get a graph that looks like this. We're just going to cross over here at 4, and the next at like 4, 5, 6, that'll be at 4 as well. You don't need that y equals 4, I'm just doing that for fun. But, so here's our graph. Unfortunately, it kind of looks like a smiley face now, but we don't know, oh, I didn't need to circle that. We don't know where those x-intercepts are. We know they're both negative, but we don't know the values, and that's because they're going to be irrational numbers. So we got to do a little journey back through our brains from algebra 1 to algebra 2 and say, how can we find the x-intercepts of something like this or this? Well, in this case, having the general form is going to be easier. You could always try factoring, but if they're not nice numbers, if they're not rational numbers, like they're not whole numbers or fractions, this factoring is not going to work. So what we're going to do is we're going to use the good old quadratic formula. Hooray! Which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm not going to sing it for you because I don't want to break my phone. Because if I sing into my phone, it might break, so I'm that bad at singing. But I'm sure you can just YouTube quadratic formula song, because you're already on YouTube, and you can find someone singing it. If that helps you remember. That's a C, not a square. C. Right? So we've got ax squared plus bx plus c. And we can just go ahead and use that quadratic formula, find our x-intercepts. Because the quadratic formula is the solutions to this equation. Ax squared plus bx plus c equals 0, you use the quadratic formula. When we're finding x-intercepts, we're solving when the equation is equal to 0. So we just go here, go, all right, well, x equals negative b. That's a negative 6, plus or minus square root b squared. 36 minus 4 times a, which is 1, times c, which is 4, all over 2 times 1. Whoop. So we get negative 6 plus or minus square root 36 minus 16 over 2. Negative 6 plus or minus square root of 20 over 2. Ooh. We gotta simplify the square root of 20. Remember? Yeah, we did this back like day 1. So we take the 20 and we say, what numbers live inside of 20? 4 times 5. Square root of 4 is 2. So we get 2 square roots of 5. So I have negative 6 plus or minus 2 square roots of 5 over 2. And I can simplify this to negative 6 over 2 plus or minus 2 root 5 over 2, which gives me negative 3 plus or minus square root of 5. Those are not our x-intercepts. Those are the solutions to when this is equal to 0. To write our x-intercepts, we just got to write these as points. Okay, let's do that. So one of the points is negative 3 minus square root of 5, comma 0. And the other one is negative 3 plus the square root of 5, comma 0. And that makes sense because the square root of 5 is a little bit bigger than 2, less than 3, right? The square root of 4 is 2, square root of 9 is 3. So it should be between 0 and 1, and it should be between 5 and 6, which they are. So we're good. Cool. So in order to find the x-intercepts, just use quadratic formula and then write them as points. Let's do another one. This one will be slightly more complicated, of course. Sorry, I'm bringing it up on my computer so you get a nice shot of the top of my head there. Here we go. All right. I'm going to keep this stuff up. Yeah, because it's the same instructions. Same instructions, a little bit more challenging problem. So here we have negative 3x squared plus 24x minus 45. That's our new equation that we're going for here. Woohoo! All right. So, erase all of this. First step, we want to get this in standard form. Remember, standard form is this vertex form. That's what the book means when it says standard form. It means make it look like that. So let's do that. Oh, I just about took out my whiteboard. Hold it down. And we're going to do this by completing the square. This is different though. Well, it's not different, it's the same, but it's more challenging. There's an extra couple steps in here. So we have f of x equals negative 3x squared plus 24x minus 45. Let's just look at this part here. Let's not worry about the f of x. It'll stay f of x the whole time. What we want, remember, is that a times x minus h squared plus k. Here, we have a negative 3 in front of the x squared. That's going to be our a value. What we need to do is we need to factor that out of all of the x parts. So I'm going to factor this out by dividing each part that has an x by negative 3. And that negative 3 is going to plop out front, factored out, and I'm going to get an x squared, because negative 3 divided by negative 3 is 1, so I have 1x squared. You should always have 1x squared inside here. And then 24 divided by negative 3 is going to give us a minus 8x. And then I'm going to go plus blank, parenthesis, minus blank, minus 45. So here, I've got my negative 3 times, I want this to be a perfect square. So I got to figure out what number makes this a perfect square. And then this other stuff, right? I got to make sure I'm adding the same number and subtracting that same number. Whatever number I put here, I got to do the opposite of it here. Okay? So remember the trick to finding what makes this a perfect square is to say this negative 8 divided by 2, that gives us negative 4, square it, and we get a 16. All right. So we get that 16 there. But are we really adding 16? Should I go minus 16 here? Not really. What we're doing is we're adding 16 negative 3 times. So what we're really doing is we're subtracting 48 because 16 times negative 3 is 48. So this is really, this is minus 48 here. So what I got to do to make it even is I got to add a 48. Go over that one more time. I add 16 inside the parentheses. So now I have negative 3 16s. And negative 3 times 16 equals negative 48. So really this expression got 48 smaller by putting this 16 in here. I want it to be the same as this expression. So I got to do the opposite of that 48 smaller by making it 48 bigger with a plus 48. And now this is the same as this. They're the exact same now. They're written differently, which is what we want. We want it written differently. So I now have my negative 3. I can factor this. We can draw the box and do that sort of thing. Or we can remember our special products. And this gives us an x minus 4 squared, right? Because negative 4 times negative 4 is 16. I'll get a negative 4x twice, which would be negative 8x, x times x squared. And then here I get a plus 3, because 48 minus 45 is 3. Ta-da! F of x equals, right there, let's get it, standard form. That is our standard form. Bam! Yeah! So f of x equals negative 3 times x minus 4 squared plus another 3. All right, cool. So, hey, we got the vertex now. The vertex is going to be at 4, 3. Opposite of this number for the x, that's our y. Axis of symmetry is always x equals that number. X-intercepts, let's see if we can get them for free. Let's go ahead and graph. Here we go. And we're on the right-hand side with our start. So we're 1, 2, 3, 4. That's our axis of symmetry. Draw that axis in there. And then 1, 2, 3. 1, 2, 3, 7, 8, 9. All right, so I'm going to put my vertex at 4, 3. And then I know that there is a reflection because of this negative reflection in the x-axis, so we're going down now, which means the vertex is the maximum. And then it's a stretch, a vertical stretch by a factor of 3. So I'm going to go right 1 down 3, left 1 down 3, because normally it's right or left 1 up 1. I just multiply that up 1 by negative 3. Now it's down 3. Normally if I go 2 over, I go up 4. Now I'm going to go down 12 because 4 times negative 3 is 12. So from 3 down 12 is negative 9 because that's 12 away. And same on this side. That's enough for the graph. There we go. And check it out. Check it out. Right? X-intercepts. Boom. Boom. We got them for free. Right? They came with the graph. The bonus deal. 3, 0, that's our smaller x-intercept. 5, 0 is our larger x-value x-intercept. Woohoo! If they didn't come for free with this deal, we would just solve negative 3x squared plus 24x minus 45 equals 0. either using the quadratic formula, you could divide everything by -3, now that it's equal to 0, and then try to factor it. You could do that. Lots of options there. Okay. We have one more problem to do, and that's it for the video. So I have no idea how long this is, how far through it is. Hopefully it's not too long. I feel kind of bad for making these so long, but I can only talk so fast, and I want to give you plenty of examples and stuff to work on and take notes on. All right. Let's say we have a quadratic function. So we've got a quadratic function whose parabola, the graph, has a vertex of, let's just say it's -3, 5, and it goes through the point 1, 7. What's the equation? What is the standard form equation? That's what we're looking for. All right, and remember, the standard form equation is this one. It's what we used to call vertex form. Well, what information do we have? We have the vertex and another point. So, basically, if I'm going to graph this up, graph it up. It's going to get a little graphic. Sorry. 1, 2, 3. 1, 2, 3, 4, 5. There's our vertex. And then I've got the point 1, 7. 5, 6, 7. So there's the other point. So we know there's going to be another point. What is 1, 2, 3, 4? 1, 2, 3, 4. We get a graph that's going to look something like that. So here, this graph is like not very steep, right? You can see it's kind of squashed down. It's got probably a fairly decent sized vertical shrink on it. And that's what we're going to try to find. What is that vertical shrink? Because we know if the vertex is at -3, 5, we can plug that straight in, boop, to the h and the k, right? Remember, y equals a times x minus h squared plus k. This means the vertex is at h, k. So what we do is just go, all right, well, y equals a times x minus h. The h here is -3, so it's going to be a +3 squared, because the +3 denotes a shift left 3, which is what we got going on here. And then +5. +5 because it's got a vertical shift up 5. All right, now what we want to do is we still want to find a. So we've got 3 things we don't know. We don't know a, we don't know x, we don't know y. But we know one value for x and one value for y that work. That's right here. The 1, 7. So here, this means x equals 1, y equals 7. When x is 1, y is 7. That is a solution to this equation. So what we got to do is we got to find what number can I put here to make it true that if x equals 1 and y equals 7, these are the same. So that's what we're going to do. We're going to go 7 for y is 7, so we replace the y with a 7, equals a times 1 for x plus 5. All right. Well, we're just going to solve for a now. So I go like 7 equals a times, oh my goodness. Don't change your 3's to 4's though. I do this a lot where like I go 1 plus 3 and I'm supposed to write plus 3, but I add 1 and 3 and I write a 4. 1 plus 3 is 4. 4 squared plus 5. Let's do that all in the same color. That looks weird. Sorry. 4 squared plus 5. So 7 equals a times 16 plus 5. You can do this in, there's different orders you can do this in. All right, now we can subtract 5 on each side. So we get 2 equals a times 16, right? Because they're right next to each other, that's implying multiplication. That's what it means. So we divide by 16. And we get a equals 1/8. Are we done? Well, pretty much always, whenever a math teacher says, are we done? You're probably not done. You probably have at least one more little step to do. So that's the case this time. We've got one more step to do, and we're going to write f of x equals, instead of a times x plus 3 squared plus 5, we're going to say 1/8 times x plus 3 squared plus 5. Resist the urge to write this as your answer. This is not your answer. This is your answer. It's asking for the standard form equation. So don't give the a value as your answer. Give the standard form equation. You can always go back to the graph and be like, hey, does it make sense? Well, yeah. If I go 4 to the right, and I only go up 2, normally I go up 16 for a regular quadratic. So 1/8 of 16, yeah, that's 2. Cool, got it, and that's it. So hopefully this is enough to get you through your homework for section 2.1. If not, hey, office hours, Friday morning and Monday after class, or Monday afternoon. Have a wonderful day, hope you have a great weekend, and thanks for watching.